When technically trained professionals first begin working with large language models, one of the most surprising discoveries is how different these systems are from traditional software. Engineers are used to interacting with deterministic systems that behave exactly as specified. If a program receives the same input twice, it produces the same output twice. Language models do not behave in quite the same way. They generate responses by predicting tokens according to probability distributions that depend on context, training data patterns, and generation parameters. Because of this, interacting with them effectively requires a different mindset. Prompt engineering emerges as the discipline of shaping the model's behavior through carefully designed instructions. However, beginners often approach prompt design with assumptions inherited from traditional programming, and those assumptions lead to a series of common mistakes. One of the most frequent mistakes is assuming that the model fully understands intent in the way humans do. Humans rely heavily on shared background knowledge, implicit assumptions, and contextual understanding. In everyday communication, people rarely spell out every detail of what they mean. When speaking with another human, leaving things unsaid often works because the listener fills in the gaps. Language models cannot reliably do this. They only see the tokens that appear in the prompt, and they respond according to patterns associated with those tokens. If the prompt leaves important elements unspecified, the model must infer them statistically. Sometimes the inference will match the user's intention, but often it will not. Beginners frequently blame the model when the output diverges from their expectations, when the real issue is that the prompt did not communicate the task clearly enough. Another common mistake involves writing prompts that are too vague. A prompt might say something like "analyze this text, improve this paragraph, or explain this concept." While these instructions sound reasonable to a human reader, they leave enormous room for interpretation. Analysis could mean summarization, critique, extraction of themes, evaluation of arguments, or identification of entities. Improving a paragraph might mean making it shorter, clearer, more persuasive, more formal, or more technically accurate. Without explicit guidance, the model chooses one interpretation based on patterns in its training data. Beginners are often surprised when the output focuses on aspects of the text that were not the intended focus of the task. Closely related to vague prompts is the mistake of assuming the model automatically understands the desired output format. By default, language models generate natural paragraphs of text. If the task requires a list, a table, structured data, or a particular sequence of labeled sections, the prompt must specify that structure. Beginners often ask complex questions and expect the answer to appear in a specific format without explicitly requesting it. When the model returns a free-form explanation instead of a structured response, the problem lies not in the model but in the lack of formatting instructions. Another frequent error is the opposite of vagueness, providing too many instructions at once. New users sometimes attempt to control every aspect of the output by including large numbers of constraints in a single prompt. The prompt may simultaneously request a concise explanation, detailed examples, creative insights, formal tone, technical depth, and strict formatting. Each of these requirements influences the probability distribution of possible outputs. When they conflict with one another, the model must compromise between competing signals. The resulting output may partially satisfy several instructions without fully satisfying any of them. This leads to an important lesson in prompt engineering. Clarity does not mean verbosity. Writing a very long prompt does not automatically produce a better result. In fact, excessively long prompts can dilute the influence of the most important instructions. Because the model must allocate attention across the entire prompt, unnecessary text can weaken the signals that define the task. Beginners sometimes include long background explanations that do not actually affect the task. Removing irrelevant context often improves performance. Another mistake involves misunderstanding the difference between deterministic and creative prompts. Beginners often expect the same prompt to produce both precise analytical results and imaginative exploration. These goals require different prompting strategies. Deterministic tasks benefit from tightly constrained instructions and clearly defined output structures. Creative tasks benefit from prompts that allow flexibility and open-ended thinking. Attempting to force creativity within a rigidly constrained prompt often results in bland or repetitive outputs. Conversely, attempting to produce precise analytical results from a highly open-ended prompt often leads to inconsistent answers. A related misunderstanding occurs when beginners expect language models to perform complex reasoning instantly without guidance. Many technical tasks require multiple reasoning steps. If the prompt asks only for the final answer, the model must internally compress all reasoning into a single transition from problem to conclusion. This compression sometimes leads to mistakes. Step-by-step prompting often improves reliability by encouraging the model to articulate intermediate reasoning stages. Beginners frequently overlook this technique and instead attempt to refine the wording of a direct answer prompt repeatedly. Another common error arises from inconsistent prompt structure. When instructions, examples, and context are mixed together without clear boundaries, the model may struggle to determine which parts of the text define the task and which parts merely illustrate it. For instance, if examples are embedded within explanatory paragraphs, the model might treat them as narrative content rather than demonstrations of a pattern to follow. Clear separation between instructions and examples helps the model identify the intended structure. Beginners also tend to underestimate the importance of examples. Few-shot prompting, which provides several examples of input-output pairs, can dramatically improve performance on tasks that involve specific transformations or formats. However, examples must be chosen carefully. If the examples contain inconsistencies or errors, the model may reproduce those problems in its response. Providing clear, well-structured examples is often more effective than writing long explanations of the task. Another mistake involves assuming that the model always uses the most recent instructions in the prompt. Because the model processes the entire prompt as context, earlier instructions remain influential. If earlier instruction contradicts a later one, the model may attempt to reconcile both signals. Beginners sometimes add new instructions at the end of a prompt without removing outdated ones, creating hidden contradictions that confuse the generation process. Overconfidence in the model's factual reliability is another frequent beginner mistake. Language models are trained on large collections of text that include both accurate information and inaccuracies. The model does not have direct access to a database of verified facts. Instead, it generates responses based on patterns it has learned. When prompted for information that is rare, ambiguous, or outside its training distribution, the model may produce answers that sound plausible but are incorrect. Beginners sometimes assume that fluent language implies factual accuracy. Experienced practitioners learn to verify important claims rather than accepting them at face value. Another issue arises when beginners fail to specify the intended audience for the output. The level of explanation required for a beginner audience is very different from the level required for experts. Without guidance, the model must guess the appropriate level of detail and technical vocabulary. This can lead to explanations that are either overly simplistic or unnecessarily complex. Including a description of the target audience in the prompt often improves the quality of the response. A subtle but important mistake involves ignoring the model's tendency to mirror the style of the prompt. Language models often adopt the tone, vocabulary, and structure of the text that appears in the prompt. If the prompt is written casually, the output may also be casual. If the prompt contains precise technical language, the output is more likely to follow that style. Beginners sometimes write prompts in an informal style while expecting highly formal responses. Adjusting the tone of the prompt itself can significantly influence the tone of the generated text. Another common mistake is expecting the model to remember context from previous interactions indefinitely. Language models operate within a context window that contains the tokens visible during generation. When the conversation becomes long, earlier parts of the context may no longer influence the response as strongly. Beginners sometimes assume that instructions given many messages earlier will continue to apply automatically. Repeating key instructions when necessary helps maintain consistent behavior. Beginners also often neglect the importance of iterative prompt refinement. Prompt engineering is rarely a one-step process. Even well-designed prompts may require adjustments based on observed outputs. Instead of treating prompt design as a static specification, experienced practitioners treat it as an experimental process. They observe how the model responds, identify where misunderstandings occur, and refine the wording accordingly. Another frequent mistake is focusing too heavily on clever phrasing rather than structural clarity. Some beginners believe that special wording tricks can unlock hidden capabilities in the model. While phrasing does matter, the most important factor is usually the clarity of the task definition and the structure of the prompt. Clear instructions, well-chosen examples, and explicit formatting requirements consistently outperform clever but ambiguous wording. There is also a tendency among beginners to treat prompt engineering as a form of persuasion, as if the model must be convinced to produce the desired answer. In reality, the model does not possess intentions or preferences. It simply follows statistical patterns in the text. Effective prompts align with those patterns rather than attempting to manipulate them through rhetorical emphasis. Another mistake involves neglecting evaluation. Beginners sometimes judge prompt quality based on a single successful output. Because language models generate probabilistically, a prompt that works once may fail in other cases. Evaluating prompts across multiple inputs helps reveal whether the design is robust. This is especially important in professional applications where reliability matters. In structured workflows, beginners may also forget to enforce strict output formats. When AI outputs are intended for automated processing, small deviations in formatting can break downstream systems. Prompts should clearly define the structure of the response and discourage additional commentary that could interfere with parsing. Finally, beginners sometimes underestimate the importance of understanding how language models actually work. Prompt engineering becomes much easier when practitioners adopt the correct mental model. The model is not a reasoning engine that interprets commands logically. It is a probabilistic text generator that follows patterns in its training data. Prompts influence those patterns by shaping the context in which token predictions occur. Once this mental model becomes clear, many of the common mistakes become easier to avoid. Vague prompts are replaced by precise instructions. Unstructured outputs are replaced by clearly defined formats. Direct answer prompts for complex problems are replaced by step-by-step reasoning prompts. Creative tasks are separated from deterministic analytical tasks. Over time, prompt engineering becomes less about trial and error and more about thoughtful communication with a statistical system. Engineers learn to design prompts that guide the model's behavior in predictable ways. They recognize when constraints are necessary and when flexibility is beneficial. They learn to balance clarity, structure, and efficiency. The transition from beginner to experienced practitioner often involves unlearning assumptions inherited from traditional programming. Instead of issuing commands to a deterministic machine, prompt engineers create textual environments that shape probabilistic generation. Within those environments, the model's capabilities become far more reliable and useful. Understanding these common mistakes is therefore not merely a list of things to avoid. It is a pathway toward developing a deeper intuition about how language models respond to prompts. That intuition allows practitioners to design interactions that harness the strengths of these systems while minimizing their limitations.
If you find this video exciting, please like, subscribe, and turn on notifications. See you in the next AI for Beginners educational video.